Good afternoon, everybody. So this is the question. This is the doubt of one of my friends. So that I am going to explain. That the power input to induction motor is 40 kilowatt when it is running at 5% slip. The stator resistance and core loss are negligible. So the torque developed in it is basically it was given in the synchronous watt. Okay. So this was the question. So let me explain you how you should proceed in such questions. So what you have to do is we have this induction. This is the induction motor block diagram. Induction motor block diagram. Okay. So what happening in this is induction motor block diagram. So you need to understand. Then only you will be able to do good questions. This is stator. This is induction motor stator in which a three-phase supply is given. Okay, so in this stator we have two losses, stator core loss and copper loss. Okay, then the stator output is nothing but the rotor input. Okay, so rotor also have two losses generally. We'll neglect rotor core loss, rotor copper loss, and then we have rotor output. Okay, here we have, if you suppose in some question it is given that to calculate the shaft power, then you have to subtract this windage and friction loss or friction loss. You have to subtract this also. Okay, so this is what you need to keep in mind while solving a question. So this is block diagram. The three-phase power is given. What is this stator output or rotor input? If you find out, how you will find out that rotor input is nothing but it is what stator input, P input, what is power is given, minus stator copper loss, stator core loss, minus stator core loss, and minus stator copper loss. Okay, generally copper loss is neglected, so we generally consider core loss. Okay, so I hope it is clear. So just I am focusing on question now, that how you are going to do. See, in this given question, actually, what is given is that it is given that it does not have any stator core loss. Okay, it is written that stator resistance and core loss are negligible, which mean that you have to neglect the stator core loss and copper loss. You have to neglect it. So what it mean that whatever power input is given to this stator, it is nothing but the stator output or the rotor input. Okay, but you need to remember this, that you have to always, whether it is given or not, but you have to consider a rotor copper loss always. You have to consider rotor copper loss. Okay, so what is this rotor copper loss? Equals to slip times rotor power input. Okay, now in this case, since stator core loss is given as 0, therefore what we will say that the power input to stator is nothing equal to the power output. Okay, so as time rotor power input. So listen, rotor power input is nothing but the power input. That is, since these values are given as 0, therefore rotor input will be what? Same as power input. Okay, and for this, for torque develop, you need to know what is what is the power available at the rotor, at the output of the rotor side. For torque develop, you need to know this quantity. Okay, so this is rotor copper loss, this slip time rotor power input. So this is slip 5% into rotor power input. Rotor power input is what? 40 kilowatt it is given. Okay, so it becomes 2 kilowatt. So this is what? This is rotor copper loss. Now, for calculating torque develop, you need to know what is the power at the rotor output. So for that, input power minus rotor copper loss equal to 38 kilowatts. So this is what the rotor output. Okay, so C is the right answer for this question. I hope it is very clear how C is coming. Simply you need to remember this is the block diagram of induction motor. Okay, so whether it is given or not, but you have to calculate this rotor copper loss. Okay, and if suppose if the rotor core loss are given as 1 kilowatt. Okay, if it is given that in this question it is given an example, but if 1 kilowatt is given to you, then what you will do, you will subtract, like 40 kilowatt is the input, you will subtract 1 kilowatt, and 39 kilowatt is the rotor input. Okay, so whatever it, yeah, here it will be for 39. Okay, so you have to consider that. So you have to subtract that. Since it is given as 0, so it will be simply 0. So for torque developed, you need to know the rotor output. So so this is what I have done. This is rotor copper loss, and the rotor output will be input minus 2. Rotor copper loss equal to 38 kilowatt. So I hope it is clear. 38 kilowatt is the right answer. Okay. So the next question is this. This is the question of the spherical is induction motor having rated slip of 2% of full load has starting torque of 0.5 full load torque. The starting torque T starting is equals to 0.5 times T of full load. Okay. So starting current will be what? So this is asked. So this is the formula you need to remember. This is most important formula. Okay, most important formula. You should know this. That T starting is T starting. This is what T starting torque upon T full load torque is equals to I starting upon I full load torque whole square into full load slip. Okay, what is given is starting torque is what 0.5 times the full load torque. Okay, so 0.5 times full load torque in upon full load torque. I starting upon I full load torque whole square into full load slip. What is that full load slip? This is the full load slip. Okay, 2%. So this is what is written. This is what full load slip. Okay, this is what is full load slip. Okay, so this get cancelled. 0.5 I have transferred this to here, and then I starting upon I followed whole square. Now if you see 0.5 upon 0.02 equal to 5 by 10 into 2 into 100. Okay, so you have to cut this 2.5. So finally you will get 25. Okay, so this will be 25. Now if you take under root both side, what will be simplify. So I starting will be 5 times full load current. So D is the right answer for this question. So I hope it is very clear. So you just need to remember this formula, and this is starting torque full load torque and starting current full load current, and this is full load slip. Okay. So I hope it is clear. So please subscribe to my YouTube channel. Please subscribe for more doubts. You can share doubts in comment box. If possible, I will try to solve. Okay. So please subscribe to my channels. Thank you for this. So I hope doubts is clear. So this is the D answer, and for this question answer is C. Okay. So thank you. Please subscribe to my channel. Thank you.